We need to start the great adventure of nuclear power in France again.
France is building 6 new nuclear power plants, maybe as many as 14. And the country that produces more nuclear power than any other wants to save the climate with new nuclear power plants.
We have some really ambitious net zero goals for the climate, and nuclear power is the clean option for that.
Nowhere in the world are as many new nuclear power plants being built as in China.
The Chinese are really looking for energy wherever they can find it.
And 11 years after Fukushima, even Japan wants to build new reactors. While Germany is phasing out nuclear power, more and more countries are opting for it. Why are they doing it? And can't we save the climate without nuclear power?
Maybe one country or another can do it, but as a planet, we can't live without it, and we probably have to grow it pretty significantly.
But who can even build nuclear power plants today? And what price do you pay for it? We are going on a journey. The first stop, the political center of Washington, D.C. Policymakers here face a huge challenge. The world's largest producer of greenhouse gases wants and needs to become clean, in terms of electricity, within a good 10 years. The Department of Energy is responsible for this Herculean task.
In the context of the size and scale and variability of the grids around the United States, not just one grid, but multiple grids, of course, because it's such a large nation, making sure that the grid is reliable across all of those places does in many places require a real significant amount of firm, like ready to roll 24/7 base load energy. And right now, a lot of that is provided by unabated fossils.
Catherine Huff is a division director here at the Department of Energy. As they look to replace gas and coal, they also look to the past. More than 70 years ago, an experiment succeeded here in Idaho that could also be a solution for the future.
So we have come to a place today where hope was born. On this very spot, the United States produced the world's first electricity from nuclear energy.
On December 20th, 1951, for the first time, a reactor provided enough energy to light 4 light bulbs. The next day, it was producing enough energy for the whole building and even the lighting in the parking lot.
Nuclear has been a stalwart part of about 20% of our electric grid, creating a backbone of clean, firm power. We have a robust industry, and I think there's a real capability there that we can leverage today, right? So it's available, we understand it, it's performed well for us in the past, and we probably have to grow it pretty significantly, probably double or possibly triple the amount.
A new pile has just been connected to the grid in Georgia. A second is to follow soon. The U.S. is still firmly committed to nuclear power, and the fact that no one has as much nuclear waste in storage as they do doesn't stop them.
Spent nuclear fuel is important to manage responsibly, but we do that, and we have demonstrated that we can safely manage that fuel. It does need to be disposed of eventually, but there are technological solutions. We see Finland making real progress, almost ready to begin operating their repository. And those activities give us real confidence that this is a solved challenge.
Nuclear power is booming again in the U.S., and they have high hopes for a new type of small nuclear power plant, the first of which are to be built soon.
A new generation of nuclear power has learned from our decades and decades of safe operation of nuclear power plants, and those innovations have been made on paper for quite a while, and the real economic promise and the readiness to commercialize that new generation is hitting right now, right alongside the sort of challenges around climate and the acknowledgement of the importance of energy security. All of these things are converging in a moment where, I hope that the industry can meet it.
What are these new small reactors? That's what we want to find out. We are in the northwest of the U.S. At the foot of the Rockies is the largest nuclear power research center in the Western world. Only those who have a security clearance are allowed on the premises. It's a gigantic area, and there are all kinds of different research departments.
The Idaho National Lab is a U.S. Department of Energy lab. The vast majority of nuclear energy research takes place here in this lab. Pretty much all the reactor technologies that you see around the world were tested in one form or another at this site here.
Abdul Dulu has worked in the industry for many years. Now he's the chief scientist here.
So with that heritage, here the Idaho National Lab is very well positioned to host the next demonstration of the next advanced reactor technologies. That's why it's playing such a key role in this resurgence of nuclear power.
Abdul shows us the hot fuel examination facility. This is where research is being done on the new small reactors. The facility is there to safely examine highly radioactive material. This gigantic box consists of 1.5 meter thick concrete walls, interrupted only by windows made of 6-pane safety glass. All the work in here has to be done from the outside with the help of gripper arms. They are currently examining fuel rods that will later provide the energy in the power plant.
They will look at how that fuel behave under irradiation. Does it behave as predicted, as what they did a lot of calculations, of course, to predict how the fuel is going to behave. Those experiments what we do here confirm or do not confirm those calculations. So that's allow the designer to know. And that's a very important step before actually taking this, putting the fuel in an actual reactor and demonstrating and then going on to the commercial stage.
The big innovation with these reactors is that they are significantly smaller, only about a quarter of the size of current plants. They are called SMRs, small modular reactors. The idea is to take known technology and simply shrink it.
A small modular reactor is going to be, because of its smaller size, the overhead cost is of course going to be less. The other advantage of a small modular reactor, of course, is that the modular part of it means it can be assembled, in a factory and then brought to the site and placed there. So that cuts a lot also on the time and the cost.
More than 70 different such mini reactors are currently being developed worldwide, and many of them by complete newcomers to the industry.
The biggest example is like Bill Gates, right? He founded his own company, TerraPower, who is currently one of behind a couple of the advanced designs. Yes, I believe it will be a game changer in the sense that it would make nuclear power more achievable and attainable for a number of countries.
And some countries have high hopes for these small power plants. Back to Europe. Poland has so far been the absolute laggard on the continent when it comes to clean, i.e. CO2-free electricity. Here, in the center of Warsaw, the Polish oil company Orlen has established a subsidiary to take care of a clean future. Mariusz Ilnicki is the press spokesman.
Poland is in a very difficult situation because we have a high dependency on coal. Of course, we invest in renewables, but this is not the energy source that can be stable energy at any time. We believe that the best way to change this energy mix is to deploy nuclear energy plants across the Poland.
The government also sees it that way and has decided that Poland will go into nuclear power. At least 6 large reactors are to be built. If Orlen Synthos Green Energy has its way, however, not only large nuclear power plants are to be built.
We think that big nuclear power plant is not enough to secure energy and electricity for citizens and for industry.
Their plan, to install a whole fleet of SMRs in Poland. Mariusz wants to show us where one of these small nuclear power plants could be built. For this, we are going to Ostrołęka.
With SMRs, you can have it quicker, because, for example, in case of BWX 300, the construction phase is going to have 24 and 36 months. So it's much. It can be deployed much faster than large nuclear power plants, and on the other hand, the scale of these investments allows to be involved by a new type of investors. For example, the private company like Synthos or PKN Orlen, which is very difficult in case of large nuclear power plants where the investments last even decades.
Today, Ostrołęka makes its living by producing electricity, although it is currently produced from coal.
The existing coal-fired plants should be shut down successfully in coming decades. They need to be replaced with a new source of energy.
And if Orlen Synthos Green Energy has its way, nuclear power will provide the replacement. The SMR could be built on this site very close by. The advantage of these small nuclear power plants is that they provide similar amounts of electricity as coal-fired power plants, so the local power grid does not need to be rebuilt. For their power plant project, the Poles are collaborating with Toronto-based energy company OPG. The Canadians will be the first in the world to build this type of SMR.
This project will allow us to receive as soon as possible the full technical documentation necessary to deploy and to license this project in Poland. OPG, which already started preparation work and licensing process, plans to have its SMR ready in 2028. We believe that first SMR in Poland can be ready a year or two later.
Their goal is to have the first SMR up and running before the year 2030. If their ambitious plan works out, they would probably be faster than the government's major projects. And Poland is not the only newcomer. The Turkish Mediterranean coast. Here in Akkuyu, a remarkable project is being built, a huge nuclear power plant that is expected to supply 10% of Turkey's electricity in the future. It is currently one of the largest power plant construction sites in the world.
We hope that the first reactor will be in operation by the end of 2023 and electricity will be produced here.
What's special here is 4 reactors are being built side by side, one after the other, all using the same technology. This ensures a speed that makes the new construction projects in Europe or the US look old.
Today, there are 422 reactors in operation worldwide and 57 under construction. The European Union gets 25% of its electricity from nuclear power. Last year, the European Commission recognized nuclear energy as green energy and removed its reservations on this issue. With Akkuyu, Turkey will participate in this development.
The ceremony at which Erdogan spoke in the spring of 2023 was a huge milestone. For the first time, fuel elements for the power plant were delivered, and switching it on was a very special guest.
The Russian president, my dear friend, Mr. Putin.
Congratulations on this significant milestone.
On behalf of myself and my country, I would like to thank Mr. Putin and all the authorities of the Russian Federation who have supported our project from the very beginning.
The nuclear power plant is located in Turkey, but it belongs to Russia. The Russian state-owned nuclear power company Rosatom is investing $20 billion. It planned everything, is currently building it, and will later operate the power plant. Even the nuclear waste will end up going back to Russia. Turkey simply buys the electricity at a fixed price.
It's going to be a Russian plant on Turkish territory, and let's remember that Turkey is a NATO member. So having this piece of critical infrastructure on the territory of a NATO member is something that a lot of Western experts think might be, well, troublesome.
Kasper Shuleski is a professor of international relations and a sought-after expert on Russian energy policy.
There's been voices from the US, also from members like Poland, but so far nobody was outspoken enough to really question this project and to stop it. So most likely this project is simply going to move forward as if the geopolitical situation didn't change.
Turkey has tried several times to build nuclear power plants, but always without success. This time, it seemed to work, thanks to Russian help.
Every country is going to have to make that choice for themselves, right? Some partnerships are strong enough that you can trust your neighbors and partners to be, a helper in the management of your energy technologies. But we certainly we have a recognition of how, for example, Russia, in its invasion of Ukraine, has weaponized energy dependency. And I think that's something that every country is thinking about today in terms of how they plan the control that they have over their own energy supply.
But what consequences could this have for Turkey?
I mean, what kind of power Russia can exercise over a plant like the one in Turkey, that's still being debated. So you can have experts who are more, optimistic. However, especially in the light of what has been happening last year, so in 2022, with the energy sector in the context of the war in Ukraine, you know that things that do not seem plausible right now might actually become reality very soon. If there was some unannounced failure in the reactor, that might actually knock out the entire power system in Turkey, so cause a blackout. And that's a very, very big, weapon that Russia might be wielding.
We would have liked to visit the construction site ourselves and discuss these issues with those responsible. After months of talks, there was a commitment from the Russian operator, but it was only the Turkish Ministry of Energy who did not want to agree to a filming by us. Perhaps they are also rather uncomfortable with the project now.
Мы научились управлять энергией атома.
Rosatom is active worldwide.
И начали непрерывное
The Russian state-owned corporation is big in the nuclear power business.
Rosatom.
I would say that almost a half of the market is controlled by Russia. So that's really, it's the largest player out there. And that combines all the different elements, so reactor design and construction, but also fuel, which is a very profitable business. So taken together, Russia is really the largest player in the international nuclear market.
Russia is building new reactors around the globe, in China, Bangladesh, India, Iran, Egypt, and Turkey, and also in Hungary and Slovakia. And there have been talks with many other countries.
Rosatom has been quite immune to external shocks, so we didn't see any real influence of the Fukushima disaster on its global portfolio. We also didn't see a decline of investments after the 2014 conflict with Ukraine and the annexation of Crimea. And right now we are also not seeing that much of a rollback in terms of investments outside Europe after the war in Ukraine started.
How can this be? In fact, the Russian energy sector has been extensively sanctioned. Why has Rosatom been spared? We'll look into these questions later. Our journey continues. We want to understand another topic even better. Why are countries still building new nuclear power plants at all in an age of renewables? An hour north of Cologne, Germany, is the Siemens Energy plant. The company has been building various technologies for power generation for decades, so the future of electricity is naturally a huge topic for them as well.
The goal of being CO2-free by 2050 is, I think, a very important one from my personal perspective. I do believe that it's a big upheaval because basically all aspects of the energy landscape are affected, and many new technologies will be used and considerable investments will be necessary in order to be able to implement this energy transition with the very ambitious targets.
Jörn Schmucke is Senior Vice President at Siemens Energy. He sees several major challenges for a future in which renewables predominantly supply the electricity. The first, how do we ensure that there is always enough electricity?
Basically, of course, on good days, such as windy days, sunny days, I can already secure a large part of the energy supply via renewable energies. In Germany, for example, we will be able to cover about 50% of the power supply on average via renewable energies in 2022. On the other hand, there are days, even longer phases, when renewables only provide less than 10%.
At Siemens Energy, they have built a room that can be used to simulate the energy transition. What will happen in the grid if all coal, nuclear, and gas-fired power plants are shut down and only renewables supply the electricity? The one challenge is whole days or weeks with hardly any wind or sun. There is a second challenge. Even at very short notice, within seconds, renewables can cause enormous fluctuations in the power grid.
There are definitely surprises. That is, it can happen that suddenly an entire wind farm doesn't deliver any power. That means that 500 megawatts are suddenly missing. And that, of course, presents the grid with enormous challenges. And grid stability is then of great importance.
If you want to stabilize the grid without nuclear power, there are two other options to balance these fluctuations in a CO2 neutral way. The first is hydrogen power plants. The second is energy storage.
With hydrogen, I think we're still at the beginning. We have made enormous progress. But when I look at the infrastructure side, the generation, the production of green hydrogen, we still have to achieve enormous scaling over the next few years. If I may talk about the storage area, I think the challenge is, how do you create competitive storage that is capable of storing large amounts of energy over long periods of time? I think we'll need a few more years to be able to offer a competitive solution here.
Both ideas are promising, but no one can guarantee whether they will one day really achieve what is hoped for today. And that's exactly why many countries continue to rely on nuclear power, or are even getting into it.
The fact is that there are over 400 nuclear power plants that are in operation and about 50 that are under construction. So nuclear is still very relevant for different countries. It has the advantage of high energy efficiency. It has the advantage of high capacity with enormously high security of supply. But it has, of course, the challenge of high costs and the issue of disposal of radioactive waste.
All around the world, more and more countries are aiming for a similarly high share of nuclear power, around 20%. The goal, more stable grids. So what should the electricity mix of the future look like?
I don't think there is one answer. Every country has different conditions, including geographic conditions. Think of solar energy, hours of sunshine, or even wind conditions. In this respect, there are very different conditions, and each country basically has to manage the energy triangle and find the best balance between security of supply, economic efficiency, and ultimately, of course, environmental compatibility. So I don't think there is a single solution.
In the future, solar and wind will supply most of our electricity worldwide. How to compensate for their fluctuations? Countries will rely on different solutions for this. Back in the U.S. at the Idaho National Laboratory, T.J. Morton is conducting research in this hall. He is looking at how nuclear power plants can best be used in the future when electricity comes mainly from renewables.
The biggest challenge for a grid with a lot of renewable penetration is that gas plants or coal plants or nuclear plants operate best, most efficiently when they're 100% power all the time. So when those renewables are generating electricity, they saturate the grid, the electricity market. So there's no, the traditional power plant operators can't afford to run their plant and essentially give their electricity away for free. In an effort to couple nuclear power plants or baseload power plants with renewable energy generation, we're looking at the system behind you, which is called the thermal energy distribution system.
This plant is supposed to help when there is too much electricity on offer. Then the heat, which every nuclear power plant produces first, is to be used directly instead of converting it into electricity as usual. One option with this heat is to send it to private households or to industry.
We could use that thermal energy for manufacturing processes, chemicals, plastics. Right now, that heat either comes from burning fossil fuels or from electricity, which has come from burning fossil fuels or nuclear power plants or renewables.
The second option is to save the heat.
So this is what we are using in our system for thermal energy storage media. It is commercially available catalyst media. It's just alumina, which is a ceramic. It's got a really high specific heat capacity, so it does a very good job of storing heat. So our thermal energy storage vessel is full of these.
And the stored heat is then simply passed on later, again, for example, to industry. The third option is to use the heat in the production of hydrogen. Electrolysis.
Hydrogen plays an enormous role in our society in general. It can be used to generate power, whether it's burned as a fuel in a fuel cell for a vehicle. But hydrogen is also used in a tremendous number of everyday or aspects of our everyday lives. It requires hydrogen to produce fertilizer to grow food. I do think that nuclear power will be used to generate much more of our hydrogen in the future. So,
for the existing nuclear power plants, one can try to retrofit these options, but researchers also have high hopes for a new generation of reactors that are better suited for interaction with renewables. We continue to the next lab, the Transient Reactor Test Facility. Jim Perry, the boss here, takes us inside. Here, they're working on this next generation reactor. also called Generation 4.
The next generation of reactors have features that make them more inherently safe, to where they shut themselves down before accidents happen, that they have systems that activate under accident scenarios or off normal scenarios, to where they keep themselves within the regime that they can operate properly. On top of that, with some of the next generation reactors, they are looking for more efficiency as well, so that they can operate at higher temperatures and get more efficient power generation, as well as hydrogen production and things like that.
Hey Jim, good to see you.
Good to have you here again.
How many reactors do you want?
Jim Parry's hall is often visited by Yasser Arafat. He is leading research on a Generation 4 reactor that will be installed here.
So within this year, we expect to see components come in. By next spring, we would have the reactor assembled on the staging area. And sometime late spring or early summer, we're going to lift the entire assembled reactor and drop it into the structural frame where it's going to be standing on. And so hopefully we'll load fuel by early fall, around September timeframe. And we're hoping to go critical before Christmas of 2024.
One important difference of Generation 4 reactors compared to conventional ones, they often use a different coolant.
Today, we are entirely water-based reactor technology. But in the future, the way I see it, we're going to have a broader spectrum of water-based technologies, liquid metals, gas reactors, molten salt. It can remove a large amount of thermal heat without raising the temperature of the system very much.
Russia and China already have fourth-generation reactors running. Now the US also wants to advance this technology.
A lot of the technologies have been researched before, but they were never taken to their full capability. It's time to actually take these concepts to their end result and design better reactors.
Execute.
We went on to Silicon Valley. Here, where revolutionizing entire industries is daily business, we meet Jake DeWitt.
To be frank, like the typical model for nuclear, it won't work and it hasn't worked. So it has, we have to change. When we were starting the company, I think we had enough confidence, having seen how startups could be successful, pioneering and being able to deliver nuclear was just, it was too good of an opportunity.
Jake's goal is clear. His startup, Oklo, wants to conquer the electricity market with fourth-generation small reactors.
So we're working on basically 3 projects right now for our first 3 reactors. One of those is in Idaho, and the other 2 are in Ohio. Our goal right now is to bring that reactor online to produce power in the 2026 to 2027 timeframe. And then in Ohio, we have 2 plants coming online down there in the southern Ohio area. Those are slated for sort of 2027, 2028, or maybe 2029.
For more than 10 years, they've been working on their vision of nuclear power at Oklo. It's also about rebranding, a new image.
And for us, that was an important thing about how we also approached the design of the actual building and the plant. Not just to have it look like sort of what people are used to seeing, but something different. Something that's a little more appealing and something that's built more naturally or almost organically around what the power source is.
Generation 4 reactors, as Oklo will build them, differ in one important feature. The nuclear fission processes inside the reactor run somewhat differently, and that brings a decisive advantage.
Part of the reason we chose this technology is because you can actually take used fuel or waste from today's reactors and recycle it. In America alone, the energy content in the waste inventories, the used fuel inventories in the U.S., with our system, There's enough energy there to power the entire country for over 150 years. Pretty neat.
2 of the first reactors they're building here will provide process heat to nearby industry as well as electricity. But Oklo also has other interested parties.
There's also data centers, and I think we're seeing this rapid growth in terms of what the demand of data centers is going to be. That's been driven probably exponentially it's going to be driven exponentially, I think, by AI.
And so it's perhaps not surprising who has invested in Oklo. Sam Altman is particularly active. The co-inventor of ChatGPT is now even helping to take Oklo public. The aim is to raise $500 million to bring the mini power plants to market as quickly as possible.
Oklo has a number of advantages that I believe make them best positioned to succeed in fission. I believe that what Oklo is doing is one of our best shots to get out of the energy crisis and get into this world of energy abundance.
But as promising as it all sounds, startups working on Generation 4 reactors often have a big problem right now. They need specially enriched uranium for their power plants.
That is a massive bottleneck right now. Frankly, the West, sort of the European and American supplies just don't exist right now. The world has, as of recently, been significantly reliant upon Russia's enrichment capacities.
But part of the truth is that not only is the new generation of reactors dependent on Russia, but so are many of the traditional power plants. Back to Europe. Let's take a look at why uranium processing is such a bottleneck in the nuclear industry right now. Uranium is found in nature as ore, and it is mined in various countries. In order to be able to use it for nuclear power, it is further processed in several steps. And one of these processes takes place here at Urenco.
We are in an enrichment plant, and that means we enrich natural uranium in order to make it a fuel for nuclear reactors around the world.
Ad Louter is the boss here at Urenco in the Netherlands.
Uranium, as it is found in nature, contains only a very small fraction of U-235. That's not enough for a reactor to continue the fissile reaction. Therefore, we enrich it. That means we increase the concentration of U-235 from 0.7 to 5%. And then it's okay to use it as a fuel.
The uranium is delivered in these cylinders here to the plant. Then it is heated to gas in furnaces and sent to centrifuges. There, the uranium-235 can be collected in higher concentration. And this enriched material is suddenly in high demand lately.
To put things in perspective, in the year 2022, we have seen our order book increase by 24%, which is enormous. Yeah.
But where does this great demand suddenly come from?
Well, we have seen a major disruption last year in 2022 due to the Russian invasion in Ukraine. Many customers don't want to do business anymore with the Russians.
Doing without Russia is not easy. Although Urenco is number 2 in the international market for enriched uranium, number 1 is Russia. Before the Ukraine war, Moscow supplied nearly half of the world's demand. Many nuclear power plants in Europe and the US also buy enriched uranium from Russia.
Russia has isolated themselves, I would even say have disqualified themselves to be part of that market, yes. We have taken short-term measures in order to ramp up our production because the demand for production has increased, but on the longer term we need to invest in additional capacity. Today we cannot simply cut all relations overnight. It takes a little bit of time.
The ESA, a European Nuclear Power Authority, suspects that it could take 7 to 10 years before Europe is independent of Russian enrichment capacity. And the US also continues to rely on supplies from Russia.
If Russia decided suddenly to stop providing nuclear fuel or uranium products to Europe overnight, that would create a problem. So despite the fact that the war is ongoing and that we have sanctions in all energy sectors, the nuclear fuel sector is not being sanctioned. And there's trucks crossing the border to Finland and fuel being loaded on planes, flown to Bulgaria or Slovakia, and simply loaded into reactors there.
So are we so dependent on Russia for nuclear power that we can't impose sanctions at all?
Whether sanctions would be a problem for Europe and the US really depends on how they would be designed, what would be the target of those sanctions, how would we really imagine this happening. I expect that there will be sanctions against the nuclear sector probably this year, because I think that it's becoming politically unsustainable to keep this sector completely depoliticized and pretend that nothing is going on. How it's going to be designed, how far-reaching it's going to be, this is still an open question.
Västerås, 1 hour west of Stockholm, our last stop. Here, we will learn how difficult it could become to issue sanctions. At Westinghouse, they take care of the final step of fuel production for nuclear power plants. Enriched uranium is delivered here, and they build fuel assemblies from it.
The fuel is kind of the heart of the reactor, and it's the fuel that's actually generating the heat in the reactor to be able to produce the steam that is needed to operate a turbine and then through a generator create the electricity that the nuclear power is generating.
Aziz Dag is the CEO of Westinghouse Sweden and shows us the production process. The first step is to produce such pellets from the enriched uranium.
Basically, we say that a handful of those pellets, those small pellets, they can actually both heat and produce enough electricity for a household for a whole year.
In the next production step, the uranium pellets are inserted into thin metal tubes, the fuel rods, and about 300 of these rods are then assembled together in a rack. This is then the fuel element that later goes into the nuclear power reactor.
So each fuel design that is manufactured here is unique to a specific reactor, and each design is very unique in that sense.
We are the first journalists in several years that Westinghouse has let into this plant with cameras. We are not allowed to show certain parts of the fuel elements. The design is proprietary, and they don't want the competition to know about it. It takes years to develop fuel assemblies for a new reactor model.
It takes about 5 to 10 years to start from a piece of white paper to design, test, and verify a fuel to a specific reactor. And if there is an issue, we wouldn't have the time to develop it and to ensure that there is a continuous supply to the customer.
These long development times can have significant consequences. This has now become clear in the case of fuel assemblies for a specific power plant model, specifically the VVER 440 reactor type, a Russian development. There are currently 15 of these reactors running in the EU, and 2 are in Ukraine.
The supplier to these reactors was exclusively 12 fuel group within the Rosatom entity. So they basically had 100% monopoly for these reactors for several decades.
The situation in these two countries is particularly special. Slovakia has 5 reactors in the country, and all of them are of the VVER 440 type. Together, they supply more than half of the electricity demand. Hungary has 4 reactors in the country, and also all of this type. They supply almost half of Hungary's electricity. These two countries in particular, but also all others with these reactors, are dependent on fuel elements which were exclusively produced by Russia at the beginning of the Ukraine war.
Well, I think a lot of the market players are looking at this and basically drawing a lot of conclusion is to never be 100% dependent on one supplier. I think that's one key lesson learned.
One country had this realization earlier. Even before the war, Ukraine turned to Westinghouse. They, too, have 2 VVER 440s in the country.
End of 2019 and beginning of 2020, Ukraine decided that they also want to diversify the fuel supply. The only challenge with that was that they only have 2 reactors, whereas the rest of Europe has 16 reactors, or 16 to be. So the market is larger in Europe than well, Ukraine is part of Europe in that sense. But they embarked on that diversification program in 2020. So we started with the program, we had plans. Now, the events that happened recently just accelerated those plans.
In the summer of 2023, VVER 440 fuel rods were delivered from Sweden to Ukraine for the first time. And in the meantime, all EU countries with these reactors have also contacted Westinghouse.
Now, with the war, those discussions kind of accelerated, and it was very clear that all the customers wanted to ensure that there was a supply in case of anything could happen, or there would be any sanctions on Russia or what have you. So we have concluded a contract with Fortum in Finland, we have concluded contracts with ČEZ in Czech Republic, and we are in very final stages to also conclude contracts with Slovakia and hopefully in Hungary. I do want to emphasize that it's not a contract for the whole fleet of these customers. We have a contract where they will rely on us to supply and not necessary for the whole fleet in those countries.
Ukraine alone will be supplied exclusively by Sweden in the future. All other countries want to continue to purchase fuel elements from Russia, and it is precisely these deliveries that could prevent the EU from imposing sanctions on the Russian nuclear power sector. The world's hunger for electricity will explode in the next few years. But if we want to keep climate change in check at the same time, our electricity production will have to be CO2-free in just over 10 years.
Any talk of waiting for some additional breakthrough silver bullet technology that's going to come in the future, well, it is really distracting us from efforts that should be made right now. And if it is used as an excuse for not doing things now, but instead waiting for 2040, 2050, then it really becomes what we call climate obstruction.
Maybe it's too late to focus only on supposedly perfect solutions.
I think there is a need for the market to look at all technologies and support each other, where we see the end goal as the most important thing rather than being very politically driven about whether I like nuclear or not.
We kind of tried to pick a couple favorite things that sounded good and maybe felt good. And as a result, we've really compromised our ability to meet our broad energy objectives and climate objectives. At the end of the day, nuclear is going to play a really important part of that. And by sort of somewhat almost pretending it wasn't going to be, which is what I would call it was for the last maybe 10, 20 plus years, we've put ourselves backward in terms of being ready to take advantage of the moment.
Nuclear power could be part of the solution. But what lessons do we need to learn from the Ukraine war?
We need to be independent. As Europe, it is about sovereignty.
Actually, a nuclear sector could be a source of even higher vulnerabilities than the oil and gas sector. Since oil is such a global commodity, now with electricity, you are much more vulnerable. If something happens in the electricity sector, it might influence the economy in the entire country and the society within a matter of seconds.
Currently, Russia is ahead in nuclear power. So if the West wants to rely on this technology in the future, it needs to catch up.
So now we have to catch up, which we can do, but it's gonna take a little bit more of a concerted effort to do that.
The only question is, how much time is there?